Hi, yes, of course. Thank you, Natalie. So I am Jasmine Olvany. I am a recent alumni of the BDC Biodata Catalyst Fellowship. I was in cohort 3. I am currently actually working in the clinical trial sphere, which is a lot different than what I did for my grad studies. But I'm hoping for today to be able to illustrate you, while a lot of the steps that we take may not look or feel like they're coherent or they don't make a whole lot of sense, like they're kind of mishmashed together. I'm hoping I'm going to be able to illustrate for you that it all makes sense, and getting into professional science can be a wild ride. And a lot of the times it's the people that you meet along the way that help bolster that experience and push you to your next big thing. So with that, you can go to the next slide. Of course, you need to know a little bit about me. So you know what I'm doing now, and I'll go into that a little bit later. But where did I start? I was actually homeschooled for the majority of my general education, all the way up until 10th grade. And in that time, it was really great because I developed a lot of hobbies and found myself a very nerdy person. As you can see on the screen, it starts with Star Wars and my brother. But in that space, I didn't have a whole lot of direction for what I wanted to do with the rest of my life, just because I was constantly around my family, and my mom was a stay-at-home mom, and it was really great. But there was no take your kid to work day because I was with my mom all of the time. When I did eventually transition back into a normal high school situation, I was suddenly surrounded with all of these people who had so many years to develop where they were going, or at least think about it. And I just approached it with the idea, I'm going into this new situation. Let me take advantage of all of the things that I possibly can to figure this out. And on that way, I actually met the person. You can see the drawing here. I stole this from his Facebook. I didn't think I would take his real picture. His name was Mr. Merkel, and he only stayed at my high school for a very short amount of time. But in that time, he taught me a whole lot about chemistry. And I took some of those nerdy tendencies that I had developed when I had a lot of time to myself and kind of put it into the science field. And he saw that and he just fostered that within me. And he said, why don't you pursue this? Why don't you go forward with this? And his passion and some of his direction, because he helped me get involved in things and learn a whole lot about where I wanted to go, was really what pushed me into my undergraduate. As you can see up on the right, that is my undergraduate PI from a small college called Lebanon Valley College, who I did my first bout of research with. So we went from the high school to undergrad, where I was open to 100 more possibilities. And one of those was research with Dr. Rasmussen. That specific department that she was in, which was chemistry, also had someone called Dr. Peelan. And he is featured in this in my next step. Down at the bottom where you can see the older man and me and 3 other people, that was a RES experience he took me on for in Hungary, just because it was in chemistry and I was really excited about it, and we developed a good relationship. So he was like, hey, how about this opportunity? And I said, sure. And the 2 things that came out of this, weirdly enough, my PI that you saw on the first page, first picture, she graduated from Case Western Reserve, which ended up being my graduate school. And then Dr. Peelan, I actually went on from this experience and then was able to get a Fulbright in Budapest, Hungary. And it's not without all of their input and their help, and of course my own initiative, that I went from high school to doing chemistry research to being in Hungary to finally grad school at Case Western, where I did something completely different. And then obviously the last picture is the day that I graduated from Case Western, and I just thought it would be really good to circle back and talk about how much my family has bolstered me in each of these processes through their support. Rather than perhaps their scientific input. So go ahead to the next slide. Now we're at Case Western Reserve. And it was in my PhD that I had this really exciting opportunity with the biodata catalyst. But we actually had to take a step back because there was a lot of meeting people and they presented the next step, and meeting people and they presented the next step. And there was another bit of serendipity when I joined grad school. So I went to Case Western to do malaria research with someone called Dr. Peter Zimmerman. But how Case works, you go under an umbrella program and you have a whole bunch of time in the first semester before you have to decide which lab that you're in. And I had this weird off month where I didn't know what to do and I didn't have anyone to rotate with. And what happened was I actually rotated with this man who I forced to be in the group photo via a phone picture, Dr. Scott Williams. And joining his lab, I wasn't sure I was going to like it because it was my first endeavor into big data. And surprisingly enough, I got through that and I was like, oh, I really enjoy this, but it's not what I wanted to do. What do I do? And he gave me the opportunity to say, hey, I'm interested in malaria too. Let's make something work. And it was with him and his experience that I was actually introduced to the Biodata Catalyst Fellowship, and then obviously got that. So it was really exciting and just another sense where I made this connection with this person and it presented my next big thing, which was the Biodata Catalyst Fellowship. And I know that you guys are all here to hear about the science. So if we go to the next slide, I'm going to give you the elevator pitch just because you can't capture a whole dissertation in a very short talk. But I think it's really interesting to show how I combined what my desire was, which was malaria, with something a lot of us are a little bit more familiar with, big data. So through these two pictures, I'm kind of going to illustrate where the idea for my dissertation came from. The samples that we had when I joined with Scott, he was already getting around 6,000 individuals sequenced as part of a bigger whole genome sequencing study. And because the samples were from red blood cells and the whole blood, I thought, hey, maybe we would be able to detect the parasite that normally lives in there that causes malaria called Plasmodium. And that's what you're seeing over here on this picture that I illustrated as my graphical abstract for my dissertation. And then the more in-depth part of that was saying, okay, there's this parasite that causes malaria, Plasmodium. There are actually 4 species that cause malaria in humans. And the big problem was in those 4 species, they have a lot of areas of their genome that are similar enough that we wouldn't ever be able to differentiate between the 4 of them. And in the malaria field, there's a lot of consequence of which species you're infected with. So I wanted to figure that out. And I just did that. And what I showed you here is where I broke it down into pieces and then rebuilt it for the places that were truly unique. Now, that's good and well. It's a really great graphic, but it was actually a pretty grueling process and took a lot of computational power, which is where the first thing that was really a breakthrough for my research was the Biodata Catalyst, because this is kind of where I transitioned into doing the research on the cloud computation platform. And you can go to the next slide. And it required a whole lot of iterations. I would try something and then I would find a non-specific spot. And then I would try something and a spot would have 50,000 reads go to it. So it was a whole lot of trial and error that was taking on our local computation cluster a week to get through. When I transitioned into the Biodata Catalyst platform, I was doing these trials to try to figure out the process in what would take a week in a couple hours, if that. And it's really the only thing that got me through the initial start of my thesis. And this nice circles plot on the left of the slide is actually what we ended up with. And the final targets that we use worked really reasonably well with a detection technique that's already accepted in the field that's based on PCR. As you can see, we had an 86.2% agreement with the binary call of infected versus uninfected. And we actually found that we were pretty easily able to differentiate between the species, which I'll go into a little bit more on the next slide. So I didn't mention this earlier, but the populations that I work with are across all of sub-Saharan Africa, which is obviously an area, for those of you who aren't familiar, it's the most prevalent area of malaria. There's a lot of infection there, and I was working with some older samples, so it was even more so. And like I said, the really exciting and important part of doing all of those iterations was trying to figure out the difference between the genomes of each of the different species, which are represented here with the PF, PM, PO, and PB. It's Falciparum, Malariae, Ovale, and Vivax. And the reason that this is important, because there's this whole genetic history between the parasites where Vivax shouldn't really be all that prevalent in sub-Saharan Africa because of certain loci that humans have. So as a quick logic check before I walk you through the graph that I also put together, we're seeing really low levels of Vivax, which is really encouraging to think that we're not seeing anything that would potentially make us think that there were still non-specific areas in what I created. So what you're seeing here is the countries that we actually had individuals from, and then those pie charts are how much of each of the species we found. And we found that not only the level of infection that we saw in each of the countries pretty historically aligned with data that they were finding when they were collecting in the field, but also the proportion of the different species were shockingly similar to the things that we would expect to find in these populations. So it was really exciting and it was very rewarding to know that you could not only detect them, but figure out which species they had. So one more slide. And then I'm going to talk to you about what made the research really, really exciting when talking to other geneticists, but also for the malaria field. We pushed this a little bit further. And the funny thing was, in the beginning, when I proposed my dissertation, they said there was no way this was going to work, but you can see with certain computational power, you can make anything work with a lot of effort. We actually took this idea that, okay, we're detecting the parasite genome. How far can we look into it? Can we look at loci that have any sort of relevance for human health? And what we found was there are these really known areas of certain genes that the Plasmodium have that confer anti-malarial resistance. I've only given you one example here because it had one of the higher levels that we saw based on drug policies of the time that most of these people were collected, sulfadoxine pyrimethamine. And as you can see, the 100 there and the 18, those are percentages of the amount of reads that we picked up that had the mutation on it that made them anti-malarial resistance. So this is really cool because, you know, we started with the struggle that I didn't know how I was ever going to get over without biodata catalysts, and then pushed it into something that people were even questioning I'd be able to do. So it was really exciting, and it made this research really, really fulfilling. So if you go one more slide, I kind of want to take a step back and give you some quick lessons that I learned while working on BDC, because it was a really long, not long in the sense that it was a year-long experience, but it was a lot of things that happened all at once. So I kind of just wanted to summarize what happened. Number one, obviously, I've highlighted that the computational power behind cloud platforms like BDC is absolutely invaluable for big data research, because it took something that felt impossible and made it happen in a week or 2 weeks. You know, it was really amazing. Number two, which I haven't highlighted that much, but every grad student and even professional scientists are going to get in these seasons of life where you feel like your research is just, it's harder than it's worth and you don't know what to do. But BDC gave me all of these opportunities to say, hey, this is where I'm at, this is what I'm doing. And people got excited about that. And that made me excited about it again. So it's really helpful to just talk about your science when things like that happen. And then finally, I noticed Dave Robertson is on the call. He is integral to making this all work. Your community support, you always have to be able to put your ego aside and lean on it, because sometimes the only way to solve these problems that we get in data or research is by talking it out and leaning on other people's expertise. It was definitely a learning process for me transitioning from local cluster to cloud computation. And without Dave, it probably would have taken longer, but he really helped the entire process and many people at the BDC. So moving forward, I think that pretty well encapsulates all of the things that I did in Biodata Catalyst. Obviously, I can talk about it more. It was an enriching experience, but I think I want to draw back to how making these connections with people can really just bolster your experience and propel you forward. So, and you never know when these things are going to happen, how you're going to make these little connections with people. And I thought to tell you how this might happen organically, I would tell you how I got my current job. This is a picture of my bunny. Her name is Nibbles. I was in an interview with the current physician where I work in the clinical trial, and she hopped in my room and decided to eat a plant that I had set on the floor for the interview. And I had to stop the interview and shoo her out of the room because she couldn't eat the plant. And I was really worried that it was going to be super unprofessional. But then my boss said, "Do you have rabbits?" And I was like, "Yes, I have 3 of them." And we connected over that, and it just turned into such a positive experience. And she even jokes now that it's one of the reasons that I did land this position. Of course, I have my own accolades to thank for being able to get something like this, but I really think Nibbles helped. So if we can go one more slide, I would like to close out. Oh, sorry. I was going to tell you a little bit about what I do now. I just got this approved by the doctor that I work with. So what I'm currently doing is a little bit further out of big data than a lot of people will be familiar with. And the reason I made that transition is that the malaria research just invigorated and like made me so passionate about working with people and for people. And I thought that working into clinical trials will help me feel more connected to the populations that I was working on. So I actually joined a neurointerventionalist trial. And what that is where you work on like strokes, ischemic strokes that happen in your brain through your vascular system. And so what we're currently working on is a specific type of stroke where you have stenosis or like a blocked external carotid artery while also having an acute stroke in your brain. And the reason we're working on that, it's called tandem occlusions, is because it has a lot of really terrible disabilities. It's one of the hardest strokes to treat. And people end up being really disabled after them. So we're looking at a couple different interventions to see which helps people the most, so that we can put it forth for the field, which doesn't have a whole lot of guidelines around it right now. And that's with Dr. Osama Zadat, who is pictured there. That's his LinkedIn profile picture. He was also a member of the Case Western sphere. So there's another connection that just really helped me transition into this, and it's called Picasso. So if we want to go to the next slide, I kind of just want to leave you guys with some big ideas that I've tried to illustrate with a lot of the things that I've said today, in kind of 3 points. And some of them you'll see directly from things I say, and some of them are just, I'm hoping will help someone who's still in this process or struggling in their own way. Number 1 is chase the people, not the science. So if you notice, when I talked about Dr. Williams and the malaria research, I was really, really passionate about malaria, but Scott served as someone who could really uplift me and give me the opportunities that I needed to get through grad school. There are several situations that I've showed where it's really important that you understand that the people that you're working with will either make or break your project, especially in grad school, because it's not an isolated situation and you always have to lean on other people and their expertise. So make those connections, find those little things to relate to other people, and you'll find that somewhere in the way, it'll just all figure itself out through your effort, of course. But you never know when something silly like a bunny can help you get through the next step. So the next one is build your community, because it builds your resistance. Obviously, no matter what you're going through, whatever stage of your professional life you're in, life is going to happen regardless of your science. It's going to happen regardless of grad school. And a lot of things happened in my grad school experience. For example, the 2 women who are next to my brother, who's in the middle, graduated high school. Those are my grandparents, and both of my grandmothers died and through the process of grad school, and I dedicated my thesis to them. And of course, in that process, I still had to get through grad school. I was still actively researching. So in those moments where life just feels so overwhelming and you don't know how you're going to continue working, you just lean back on the people that you've met along the way through those connections, or your family. And it really, I think, makes you feel supported and helps you kind of contextualize all of the things that we go through as humans. You're able to wade through them with the help of others. And then my last one, I pointed out a couple times in this talk, things that I've done artistically, of course, with data, but here, this is something that I illustrated, not for an HLBI, but I think it fits pretty well. I painted this on a board for a local art fair that it went in for a juried exhibition. But I just think that everyone needs to stop thinking of science as like this so data-driven. It's this thing that we're supposed to be. So we almost want to remove the creativity from it. But it really helps, I think, to think that you all need to find that way to be creative and connect your science to other things. Because how I think about it is, without my art background or that way to relax, maybe I wouldn't have known how to illustrate those things in my thesis or make that graph of the African continent. Like, the graph originally started as like 3 separate things that were kind of all over the place and it didn't fit together. But knowing that I could do some sort of illustration, it helped me kind of combine it and think about the data in a new way. And I really think that people just need to start saying, hey, maybe I can be creative in my science, and you'll have new ideas, or maybe the art will help you think of a new way to relay your science to other people, which is really important, especially moving forward, not only for other scientists, but people outside of your fields. And when it's pretty, I just feel like it's much easier to talk about, or it might give you a new lens. So that's my little bring more art into your science. But I just want to take a second, that's the last of my slide, to absolutely thank everyone who took the time out of their day to come to this talk. I mean, we're all very busy and I really appreciate it. And I hope that someone found something that can help them in their own journey.